Ever think about how, I don't know, something like computer code, which seems so modern and abstract, actually has roots in really practical, everyday problems from ages ago? Or how just one person, one mind, hundreds of years back, could set off a chain reaction that literally changed how the whole world thinks?
It's fascinating stuff.
Well, today, that's exactly what we're diving into. We're tracing this incredible legacy back to Muhammad ibn Musa al-Khwarizmi, often called the father of algebra and algorithms.
Right.
And we've gathered quite a bit of material here, sources that really paint a picture of this Persian scholar, his ideas, and the world he lived in 9th century Baghdad.
Yeah, and our goal here, what we want to unpack for you, isn't just what al-Khwarizmi figured out. It's more about why it was such a big deal back then.
Okay.
And crucially, how those foundational ideas, those ways of thinking, are still shaping, well, everything around us, from how people calculated taxes then to the tech in your pocket now.
It really is a direct line, isn't it? Okay, you've definitely set the stage. Let's dive in. Let's really try and picture where this all kicks off. 9th century Baghdad. What was it like?
Well, it was arguably the intellectual center of the world at that point.
So Al-Khwarizmi arrives there at the court of the Abbasid Caliph, probably early 800s. And Baghdad wasn't just a city, it had the House of Wisdom.
The Beit al-Hikmah.
Yeah, which wasn't just some dusty library, right? It was this huge research center. They were translating texts from everywhere, Greek, Indian, Persian.
Actively translating and using them, building on them, it was dynamic.
Right, a real engine for knowledge.
And this is important. Al-Khwarizmi, he wasn't just copying things down. He wasn't primarily a translator. He was a problem solver, driven by very real needs he saw around him.
Okay, that's a key point, a problem solver. So what
Right.
kinds of problems in 9th century Baghdad needed, well, a whole new way of doing math?
Exactly that.
Yeah.
And that need led to his major work, Al-Kitab, al-Mukhtasar fi Hisab, al-Jabr, wal-Muqabala.
Which translates roughly to the compendious book on calculation by completion and balancing. Quite a title.
It is. And from that book, the world essentially gets algebra as a distinct field. And get this, his name, al-Khwarizmi.
Yeah.
That's where we eventually get the word algorithm.
Wow. Okay, so both algebra and algorithms trace back to this one person, this one book.
In a very direct way, yes.
And you mentioned it started with practical things, like figuring out inheritance or taxes.
It absolutely did. And what's fascinating, what's really brilliant here, is how something created for such specific local needs then just explodes outwards and becomes this fundamental tool for science, for trade, for technology. I mean, everywhere, globally.
It's amazing how practical needs can spark these universal tools.
Truly remarkable.
So let's break down that word algebra. It comes from al-Jabr. What did that mean exactly?
Al-Jabr means something like restoration or completion. It refers to a specific operation he used in solving equations.
Okay, restoration.
Yeah, think about balancing an equation. If you have a negative term, al-Jabr was the process of adding the same quantity to both sides to eliminate the negative to restore it. It's about manipulating the equations systematically.
So it's about the method, moving terms around to find the solution.
Exactly. He formalized this step-by-step process, making it rigorous, repeatable.
Okay, here's where it gets really interesting for me based on our sources. We think of algebra with X and Y, right? Symbols. But al-Khwarizmi didn't use those. He described everything in words.
Entirely in words. No symbolic notation like we use today. He would literally write out the problem and the steps.
Like the example from the source, he'd explain how to solve something like a square and 10 roots are equal to 39 dirhams.
Right, which we would write as x decimal plus 10x equals 39.
And he'd then just describe verbally how to perform the steps, like completing the square to find the value of the root or x.
Exactly. Imagine the precision needed to explain complex math purely through language, making sure the logic hold up.
It's incredible. And that book, written in words, had a massive impact, didn't it?
Oh, immense. It gets translated into Latin probably in the 12th century. Algebra and al-Muqabala.
Right.
And here's the kicker. It becomes the standard math textbook in Europe for something like 500 years.
5 centuries. That's staggering.
It is. European universities were using al-Khwarizmi's methods long before they widely encountered, say, ancient Greek algebra directly, or certainly before Newton and calculus. It really shifts the narrative.
It really does. And how did it spread?
Right.
Through places like Toledo and Spain.
Precisely. Toledo was a major center for translation. Scholars like Gerard of Cremona translated there.
Okay.
And from Spain, it moves into Italy, France, and across Europe.
And its influence shows up where?
Everywhere, really. You see it clearly in Fibonacci's famous book, The Liber Abaci.
Ah, the one that introduced Hindu-Arabic numerals to Europe, too.
The very same. Al-Khwarizmi's algebra influenced that. It also fundamentally changed European bookkeeping, allowing for more complex trade and finance.
Right, because you could actually calculate things properly.
Exactly. And it provided a much stronger mathematical foundation for the scientific advances during the Renaissance. It shows, that Western algebra arguably owes more to Baghdad's practical innovations than maybe to Athens's more theoretical side.
Which makes you ask, okay, why Baghdad? What made it the scientific powerhouse?
Well, a huge part of it was deliberate investment. The Abbasid caliphs, especially Caliph al-Ma'mun, they actively funded the search for knowledge. They sent missions out to Constantinople, to India specifically, to bring back scientific and philosophical texts. It was a conscious effort.
A state-sponsored project to gather the world's knowledge?
Pretty much. And that turned Baghdad into this buzzing center for not just math, but astronomy, medicine, philosophy.
A real intellectual hub.
And crucially, it was collaborative. It wasn't just one group. You had scholars from all over the empire. Arabs, Persians, Syriacs, Christians, Jews, all working together, debating, translating, innovating.
So that diversity was key.
Absolutely. That mix of perspectives allowed Baghdad to really rival and in some ways surpass older centers like Athens or Alexandria, especially in applying knowledge.
And in that environment, al-Khwarizmi thrives. And he wasn't just dealing with algebra, was he? He was also key in introducing Hindu numerals, the ones we use now.
Yes, hugely important. He wrote a book explaining the Hindu numeral system. Remember, Europe was mostly stuck with Roman numerals back then.
Which are terrible for actual calculation.
Exactly. Try multiplying CLX7 by XE4. It's a nightmare.
Right.
Al-Khwarizmi explained the system we now call Hindu-Arabic numerals and the groundbreaking concepts within it. Place value, where a digit's position gives it its value.
Like the 2 in 20 versus 200?
Precisely. And the most revolutionary part, the concept of zero, a symbol for nothingness that acts as a placeholder.
Which seems obvious now, but was a massive leap.
A total game changer for calculation. Multiplication, division, suddenly much, much more efficient. And yet Europe didn't widely adopt zero or these numerals for centuries.
Not until his work, translated, started circulating more widely, especially out of Spain and Italy.
That's right. It took time for the practical power of the system to be fully appreciated.
And that practicality seems central to everything with al-Khwarizmi. His algebra wasn't just theory for theory's sake.
Not at all. It was intensely practical. As we said, designed to solve real problems people faced.
What else besides inheritance and taxes?
Oh, lots. Complex Islamic inheritance laws required precise divisions of estates. Algebra was perfect for that. Calculated the zakat, the charity tax, converting weights and measures, vital for trade. Even planning things like irrigation canals, which were crucial for agriculture. You needed geometry and calculation for that.
So he was creating tools for judges, merchants, administrators.
Exactly. Math for daily life, you could say. Surveyors dividing land, merchants figuring out profit margins.
And that style you mentioned, no symbols, just words that actually made it more accessible, perhaps?
In a way, yes. He broke problems down logically. Squares, roots, numbers. His step-by-step explanations were clear and rigorous. Even scholars who maybe couldn't read, say, Greek mathematical texts, could follow his logic. It was a very effective way to transfer practical knowledge.
And it's that step-by-step approach that leads us back to his name. The Latin version, algoritmi, starts appearing in manuscripts.
Referring to the methods, the procedures derived from his work.
And over time, algoritmi just morphs into algorithm.
That's the lineage. His systematic step-by-step problem-solving method became synonymous with his name and eventually gave us the word for any such procedure.
Which is just mind-blowing when you connect it to today. Because algorithms, I mean, they run everything now, don't they?
Pretty much. Your search engine results, algorithms. Your social media feed, algorithms. Online banking, navigation apps, AI, it's all built on algorithms.
All tracing back to this scholar in 9th century Baghdad figuring out how to systematically solve equations using words.
It's an incredible thread, isn't it? The fundamental concept, a clear sequence of steps to solve a problem, that's what he formalized and passed on.
And he didn't stop at math, did he? He also worked in geography?
Right. He wasn't just a mathematician. He wrote a book called Kitab Surat al-Ard, The Image of the Earth. In it, he revised the geography of the earlier Greek scholar Ptolemy. It included coordinates, latitudes, and longitudes for thousands of places.
Thousands.
Yeah, over 2,400 coordinates for cities, mountains, rivers, from the Atlantic to, well, towards China. He helped create a much more accurate world map for his time.
Long before the European age of exploration.
Long before. It shows the incredible breadth of knowledge being synthesized and advanced in Baghdad. Another example of applying systematic methods to practical problems in this case, mapping the known world.
So, summing up al-Khwarizmi's legacy, it's vast. He didn't invent mathematics itself, obviously.
Of course not.
But he invented, or at least formalized, a way of doing math, a systematic approach to problems that just completely reshaped things.
I think that's exactly right. He created methodology, and his motivation seems clear. He wasn't just pursuing abstract ideas. He explicitly wrote, to make calculations easier for people dealing with everyday issues.
That practicality was the driver.
It seems so. He wanted to provide useful answers.
And those methods, born in 9th century Baghdad, are still alive today in the code written by software engineers. It really makes you think, doesn't it? How many other fundamental tools or ideas that we use every single day have these deep, surprising histories we just don't know about?
That's a great question. What else is hiding in plain sight whose origins would tell us something profound about how we got to now?
Makes you want to keep digging into the past to understand the foundations of our present.